Welcome to the Explainer. Today, we are tackling what is honestly probably the most massive headache in enterprise IT, and that is mission-critical database upgrades. If you work in cloud architecture, database administration, or IT ops, you know exactly what I'm talking about. You've got a very large database, a VLDB. Maybe it's running in a rack configuration with DataGuard. It is literally the lifeblood of your company. And now, you have to upgrade it. It's a daunting task for sure, but today we're going to look at a highly structured, truly elegant solution to achieve minimum downtime. Okay, let's dive into this. Here's our roadmap for today. Number 1, the upgrade dilemma. 2, the logical standby solution. 3, inside DBMS_rolling. 4, the upgrade blueprint. And finally, 5, resources and troubleshooting. But before we get to the solution, let's validate the shared pain here. Why do mission-critical upgrades still hurt so much? I mean, we've all been there, right? It's 3 a.m. on a Sunday, you're sweating over a terminal window, chugging your 4th cup of coffee, and just desperately watching progress bars. All while the support desk is already queuing up complaints from global users about the system being down. It's high stress, it's high stakes, and frankly, it's just exhausting. And that pain brings us right into Section 1, the upgrade dilemma. Let's break down exactly what makes traditional database maintenance such a massive bottleneck. When we look at traditional methods, we essentially hit 3 major walls. First is pure downtime. Historically, you just have to take the database completely offline. Actually, even if you have a physical standby database in place, the upgrade still has to happen at the primary. And during that time, neither the primary nor the standby can process transactions. Second is concurrent access. Your business doesn't sleep, but your database is totally locked out to users during this maintenance window. And third, the sheer complexity. Upgrading a massive environment is difficult, it's time-consuming, and it dramatically increases your organizational risk. So, what if we could decouple the upgrade from the downtime? That brings us to Section 2, the logical standby solution. And this brilliantly illustrates the core difference. Think about a traditional physical standby. It's a block-for-block copy, sure, but during an upgrade, it's completely offline. No transaction processing allowed whatsoever. But then, look at the transient logical standby. This is the magic key. A logical standby can actually be open in read-write mode. This means it operates totally independently of the production upgrade. It stays online, it accepts user connections, and it keeps processing transactions while all the heavy lifting happens quietly in the background. So how do we actually orchestrate this magic? Let's move to Section 3, inside DBMS rolling. Introduced back in Oracle 12c, DBMS_rolling is a PLSQL package explicitly designed to implement these rolling upgrades using Active DataGuard. It completely streamlines the entire process of upgrading your database software across a DataGuard configuration in a rolling fashion. But, and this is absolutely crucial, there's one very important caveat explicitly noted in the source material. Using DBMS_rolling does require an Active DataGuard license. No way around that. The source material gives us this definitive, game-changing takeaway. The best possible solution to use DataGuard to minimize the downtime impact is transient rolling upgrade using logical standby. This completely reframes how we handle VLDB migrations. We're no longer taking down the whole ship just to upgrade the engine. We're seamlessly shifting the load to a secondary engine while we work on the first. Now, what's really interesting about this concept is how DBMS_rolling physically divides your architecture into 2 distinct camps, the leading group and the trailing group. Think of it like a military maneuver. You have your vanguard, the leading group. The master here is the target standby, or LGM. This group bravely goes first. It gets upgraded while taking the brunt of the risk. Then you have your rear guard, the trailing group. The master here is the target primary, or TGM. Once the vanguard is safely upgraded, the rear guard is started in the new Oracle home, and thanks to flashback database technology, it just flashes back to a guarantee restore point to catch up. Brilliant, right? With the architecture clear, how do we actually run this thing? Welcome to Section 4, the upgrade blueprint. Now, the official Oracle documentation lists out some highly detailed steps, but for this explainer, we've condensed them into a clean, actionable 5-step blueprint. It flows so logically, from initializing the plan, to starting it, upgrading that vanguard we talked about, executing the critical switchover, and finally, upgrading the rear guard to finish the job. Step 1 is the planning phase. This is where you execute DBMS_rolling.init plan followed by build plan. Keep in mind, you aren't actually upgrading anything yet. This is purely where those architectural rules are established. You're simply telling Oracle which database is the leading group master, which is the trailing group master, and just laying the solid groundwork for the entire operation. Let's see how this builds into the execution phase. You run DBMS_rolling.startPlan. At this exact point, your leading group is converted into that transient logical standby we discussed earlier. You then perform the actual software upgrade on this leading group. Once it's upgraded and happily processing away, you hit the absolute critical pivot. DBMS_rolling.switch over. This is the moment the upgraded leading group takes over the primary role. And the best part? It minimizes actual client downtime to mere seconds or minutes, rather than agonizing hours. Finally, we reach finalization. Your new primary is up and humming along on the new version. Now, your old primary, which is currently sitting as the trailing group, needs to be brought up to speed. You mount it in the new Oracle home, let it catch up via redo apply, and finally, you run dbms_rolling.finishPlan to successfully conclude the whole rolling upgrade. Think about that. You've just upgraded a massive database without locking out your enterprise. Of course, we live in the real world of IT ops, and things don't always go perfectly, which brings us to Section 5, Resources and Troubleshooting. So the crucial point here is that you should literally never attempt this without your documentation safety net. The source material outlines several vital My Oracle Support, or MOS, documents. I'm telling you, bookmark these right now. Doc ID 2086512.1 is your absolute Bible. It's the complete reference for DBMS_rolling. You'll also want the SQL Apply Best Practices and Doc ID 253594.1, which is an amazing step-by-step troubleshooting example. Seriously, keep these open in a browser tab the night you execute your plan. Furthermore, our source highlights some very specific bugs and ORA errors that DBAs frequently run into out in the wild. Keep an eagle eye out for ORA 1403 or ORA 1281 during your logical standby apply. If your switchover fails, immediately check for ORA 4547, which simply means your logical standby redo apply process stopped running for some reason. And definitely be aware of specific version bugs, like bug 2254128 regarding dropping partitions with system-generated names, and, of course, the dreaded ORA 600 error covered in bug 31412209. Knowing these pitfalls exist means you can proactively patch or prep for them long before your maintenance window even begins. Which leaves us with this final provocative thought. Now that we deeply understand the power of transient logical standbys and the structured automation of DBMS_rolling, why on earth are we still taking our mission-critical databases offline at all? It is time to rethink our maintenance windows, challenge the old ways of doing things, and eliminate downtime for good. Thanks so much for joining me for this explainer. I really hope this helps you reclaim your weekends. Keep learning, keep optimizing, and I'll catch you next time.